Vietnam, 1979. A Chinese soldier crouched in a jungle clearing aimed his Type 70 rocket launcher at a Vietnamese bunker 50 meters away and squeezed the firing mechanism. The rocket ignited, but instead of launching forward, it exploded inside the tube, turning the launcher into a fragile bomb that erupted in the soldier's hands. Within seconds, he was dead, his body shredded by fragments. Within hours, Chinese commanders were ordering every Type 70 launcher pulled from frontline units. And within weeks, Beijing would quietly admit what they desperately tried to hide. Their copy of America's Law rocket was a death trap that had killed more Chinese soldiers than enemy forces.
The weapon America made simple. The M72 LAW, light anti-tank weapon, represented a revolution in infantry firepower when it entered U.S. service in 1963. Before the law, giving infantry soldiers effective anti-tank capability required heavy, complex weapons like recoilless rifles that needed crews to operate. The law changed everything. It was a disposable, single-shot rocket launcher so simple that a soldier could be trained to use it in minutes. The design was elegantly straightforward. The launcher consisted of two telescoping fiberglass tubes. A soldier extended the tubes to arm the weapon, aimed through pop-up sights, pressed a button, and a 66-millimeter rocket blasted toward its target. After firing, the empty launcher was discarded. The weapon weighed just 5 pounds, could penetrate 200 millimeters of armor, and cost only about $750, cheap enough that losing one in combat wasn't a significant financial loss. By the early 1970s, American laws were proving devastatingly effective in Vietnam. U.S. and South Vietnamese troops used them against bunkers, fortifications, and the occasional North Vietnamese tank. The weapon's simplicity meant that even poorly trained soldiers could employ it effectively. Its light weight meant that infantry squads could carry multiple laws, giving them firepower that previously required dedicated anti-tank teams. Chinese military observers in Vietnam watched with intense interest. China's infantry still relied on cumbersome anti-tank weapons, heavy, recoilless rifles, and rocket-propelled grenades that required skill to use accurately. If China could produce law copies, their infantry would gain the same lightweight, simple firepower that American troops enjoyed. And unlike complex weapon systems, the law seemed simple enough that reverse engineering should be straightforward. The opportunity came in the early 1970s when Chinese intelligence operatives acquired several M72 LAWs through North Vietnamese allies. Some were captured from South Vietnamese forces. Others were liberated from American supply depots, and a few may have been purchased through gray market arms dealers. By 1972, several LAW examples had reached weapons research facilities in China, where engineers began the process of examination and copying.
The deceptive simplicity. Senior engineer Wu Jianguo received the law specimens at State Factory 247 in Sichuan Province in late 1972. His initial reaction mirrored what many Chinese engineers felt when examining American weapons. This looks almost too simple to be effective. The law was essentially two tubes, a rocket, and a basic firing mechanism. Surely Chinese industry, which had been building rockets for space programs, could replicate this straightforward weapon. This is not a sophisticated system, Wu told his team during their first examination. The Americans have built a weapon so simple that any soldier can use it. We've built ballistic missiles that travel thousands of kilometers. Building a small rocket that flies 200 meters should be trivial by comparison. I estimate we can have prototypes ready within 6 months and begin production within a year. This confidence would prove catastrophically misplaced. What Wu and his team didn't understand was that the law's simplicity was the result of years of development and sophisticated engineering. Every component had been optimized through extensive testing. The materials, dimensions, and manufacturing processes reflected accumulated expertise that wasn't apparent from examining finished products. The team began systematic disassembly and analysis. The fiberglass tubes were cross-sectioned and examined microscopically to determine fiber type, weave pattern, and resin chemistry. The rocket motor was carefully disassembled to analyze propellant composition and grain geometry. The shaped charge warhead was sectioned to study the explosive type, copper liner configuration, and fusing mechanism. Every component was measured, photographed, documented, and analyzed. Each examination revealed complexity hidden beneath apparent simplicity. The fiberglass tubes weren't just any fiberglass. They used specific glass fiber types with particular strength characteristics, woven in patterns that provided strength in specific directions while maintaining light weight. The resin system had to provide structural rigidity while remaining flexible enough that the tubes could telescope smoothly without binding or cracking. The rocket motor presented even greater challenges. The propellant had to ignite reliably, burn consistently across a wide temperature range, and generate thrust without creating excessive pressure that could burst the lightweight launcher tube. The nozzle geometry was critical. Too small, and pressure would spike dangerously. Too large, and the rocket wouldn't achieve adequate velocity. The shaped charge warhead was perhaps the most sophisticated component. The copper liner had to be formed with extreme precision. Variations in thickness of even a few hundredths of a millimeter would affect penetration performance. The explosive charge required consistent density throughout. Voids or variations would create asymmetric detonation that would reduce effectiveness. And the fusing mechanism had to withstand the shock of launch, arm reliably during flight, and detonate at exactly the right standoff distance from the target. "We're seeing complexity we didn't anticipate," reported materials specialist Dr. Chen Hua after months of analysis. The Americans have optimized every component through years of development and testing. We can identify what they've done, but replicating it with our manufacturing capabilities will be challenging. Our fiberglass isn't identical to theirs. Our propellant chemistry is different. Our copper forming processes can't match their precision. We can build something that looks like a law, but whether it will perform reliably is another question. Wu noted Chen's concerns but felt compelled to proceed. The program had political backing at high levels. Chinese military leadership wanted law equivalence for the infantry, and failure to deliver would reflect poorly on everyone involved. The path forward was clear. Proceed with available materials and processes, accept some performance compromises, and hope that Chinese manufacturing could produce adequate results even if not matching American standards perfectly.
Manufacturing shortcuts and hidden dangers. Production of prototypes, designated Type 70, began in 1973. From the beginning, the program was characterized by compromises and shortcuts driven by manufacturing limitations and political pressure to show rapid progress. The launcher tubes proved immediately problematic. Chinese fiberglass manufacturing used different materials and processes than American production. The tubes that emerged from Chinese factories were either too heavy, negating the weight advantage of a disposable launcher, or too weak, raising concerns about whether they could withstand firing pressures safely. Engineers split the difference, producing tubes that were somewhat heavier than the LAW, but hopefully strong enough to be safe. "We're not confident about tube strength," admitted the production supervisor during a review meeting in early 1974. "Our quality control testing shows significant variation from tube to tube. Some exceed minimum strength requirements with comfortable margins. Others barely pass. We've implemented sorting procedures to reject the weakest tubes,
but we can't test destructively without destroying inventory. We're accepting some tubes that we're not certain are safe, because rejecting everything marginal would make the production rates politically unacceptable. The rocket motor development was plagued by inconsistencies. Chinese propellant chemistry had improved over previous decades, but still lagged American capabilities in producing formulations that performed consistently across wide temperature ranges. Test firings revealed that propellants working acceptably at room temperature might generate excessive pressure at high temperatures or insufficient thrust in cold conditions. Temperature sensitivity is our biggest problem, the propulsion engineer reported. The American LAW works reliably from negative 40 degrees Celsius to plus 60 degrees Celsius. Our propellant works adequately from about 0 degrees Celsius to plus 40 degrees Celsius. Outside that range, performance becomes unpredictable. We could develop better propellants, but that would require years of research. We're being told to proceed with what we have. The shaped charge warhead was perhaps the most compromised component. Chinese explosive manufacturing could produce adequate warheads under controlled conditions, but consistency was poor. One warhead might penetrate 180 millimeters of armor as designed. The next might penetrate only 120 millimeters due to variations in explosive density, liner forming, or fuse timing. We're seeing warhead performance variations that would be unacceptable by American standards, explained weapons effects specialist Major Louis Kong. Some of this comes from our copper forming processes not matching American precision. Some comes from explosive density variations, and some comes from fuse timing inconsistencies. Soldiers need reliable performance. They need to know that when they fire at a target, the warhead will work as expected. We can't guarantee that with current manufacturing. Again, concerns were noted and set aside. The Type 70 would be less reliable than the American LAW, but it would be adequate for Chinese needs. Quality control would catch the worst defects, and any problems would be discovered through testing before the weapons entered service, or so engineers told themselves, ignoring the voice in their heads warning them that they were building weapons that could be dangerous to the soldiers using them. By early 1975, Factory 247 had produced approximately 200 Type 70 launchers for testing and evaluation. The weapons looked superficially similar to the M72 LAW, the same general configuration, similar weight, comparable specifications on paper. But beneath the surface similarities lurked fundamental flaws that would soon reveal themselves in the most tragic way possible.
The test that revealed nothing. Initial testing of the Type 70 in 1975 was conducted under carefully controlled conditions that masked the weapon's problems. Firings took place at moderate temperatures using carefully selected ammunition from the best production batches, with experienced personnel operating the weapons. Under these idealized conditions, the Type 70 performed adequately, not matching M72 law reliability or effectiveness, but functioning well enough to suggest it could serve as an acceptable infantry weapon. Test reports emphasized successes while downplaying problems. When warheads failed to detonate or achieved poor penetration, it was attributed to individual defective units rather than systemic manufacturing issues. When launchers occasionally cracked during firing, it was blamed on handling damage rather than inadequate tube strength. The narrative presented to senior leadership was that the Type 70 had some quality control issues but was fundamentally sound and ready for production. We're seeing a success rate of approximately 85% in testing, Wu reported to military procurement officials in mid-1975. This is lower than the American law's reported 95% reliability, but acceptable for Chinese infantry needs. We recommend proceeding with limited production to conduct field trials while we continue refining manufacturing processes. The recommendation was accepted. By late 1975, Factory 247 was producing Type 70 launchers at a rate of several hundred per month. The weapons entered military stockpiles and were issued to selected units for familiarization and training. Chinese infantry soldiers, eager for modern anti-tank capabilities, welcomed the new weapons enthusiastically. Finally, they would have lightweight, simple firepower comparable to what American troops carried. But the controlled testing conditions bore little resemblance to actual combat use. Combat meant temperature extremes, rough handling, weapons fired by stressed soldiers rather than careful technicians, and no ability to carefully select ammunition from the best production batches. The Type 70's hidden flaws that had been masked by carefully controlled testing, would be brutally exposed when the weapons were used under actual field conditions.
The 1979 Catastrophe. The Sino-Vietnamese War of February-March 1979 provided the Type 70's baptism of fire and revealed it as a death trap. Chinese forces invading Vietnam carried Type 70 launchers as standard anti-tank weapons. What followed was a disaster that exposed years of manufacturing incompetence and quality control failures. The problems began almost immediately in the tropical heat of northern Vietnam, where temperatures exceeded 35 degrees Celsius. Propellants designed and tested at moderate temperatures generated excessive pressure. Launcher tubes, already marginal in strength, couldn't withstand the increased pressures. Rockets sometimes exploded inside tubes during launch, turning the lightweight fiberglass launchers into bombs that killed or maimed the soldiers firing them. Private Wang Deshang, 22nd Infantry Regiment, died in the first week of fighting when his Type 70 exploded during firing. The rocket ignited but never left the tube. Instead, it detonated inside the launcher, sending fiberglass fragments and burning propellant through Wang's chest and face. He died within minutes, becoming one of the first Chinese casualties, not from enemy fire, but from defective Chinese weapons. Wang wasn't the only victim. Throughout the campaign, Chinese soldiers reported Type 70 failures at rates that shocked commanders. Rockets that failed to launch, leaving live munitions in tubes that had to be carefully disposed of. Warheads that failed to detonate on impact, leaving soldiers vulnerable after expending their anti-tank weapon. And most terrifyingly, catastrophic launcher failures that killed or wounded the users. We're seeing failure rates approaching 40%, reported Colonel Zhang Ming, artillery officer for the 41st Army, in a situation report sent to higher headquarters. Soldiers are becoming afraid to use the Type 70s because they're almost as dangerous to the user as to the enemy. We've had at least 15 confirmed cases of launcher explosions causing casualties, and probably more that haven't been officially reported. I'm ordering my units to stop using Type 70s until we can determine what's wrong. Similar reports flooded in from units across the front. The Type 70, which was supposed to give Chinese infantry modern anti-tank capability, was instead degrading combat effectiveness and killing Chinese soldiers. Within 2 weeks of the invasion, Chinese commanders were quietly ordering Type 70s pulled from frontline units and replaced with older, heavier, but more reliable weapons. The political implications were severe. China had invested years and significant resources developing the Type 70. The weapon was supposed to demonstrate Chinese ability to field modern infantry weapons. Instead, it was failing catastrophically in combat, exposing Chinese manufacturing deficiencies and quality control failures. And the failures couldn't be hidden. Too many soldiers had witnessed Type 70s exploding, too many casualties had resulted from weapon failures, and too many commanders were reporting problems for the issue to be suppressed.
The investigation and cover-up. An emergency investigation was launched while the Sino-Vietnamese War was still ongoing. A team of weapons specialists was dispatched to Vietnam to examine failed Type 70 launchers and interview soldiers who had experienced problems. What they found confirmed every concern that had been raised and ignored during development. The launcher tubes showed quality variations that explained the catastrophic failures. Some tubes were manufactured to adequate standards, but others contained voids in the fiberglass, improper resin curing, or structural weaknesses that made them prone to failure under pressure. Quality control had been inadequate, with inspectors passing marginal tubes to meet production quotas. The propellant batches showed dangerous inconsistencies. Some produced acceptable pressures across temperature ranges, but others generated excessive pressure at high temperatures, the exact conditions encountered in Vietnam. The propellant quality control process was revealed to be fundamentally flawed, with testing inadequate to catch dangerous variations. The shape-charge warheads showed the poor performance that had been identified but ignored during development. Many warheads failed to detonate or produced poor penetration due to manufacturing defects. The copper liners varied in thickness and formation quality. The explosive charges contained voids and density variations, and the fusing mechanisms were unreliable, sometimes failing to arm properly during flight. The Type 70 should never have entered service, the investigation report concluded. It suffers from fundamental manufacturing quality problems that make it unsafe and unreliable. The weapons testing program failed to identify these problems because testing was conducted under controlled conditions that didn't replicate combat use. Production quality control failed to reject defective units because inspectors faced pressure to meet quotas. The result is a weapon that has killed Chinese soldiers and degraded combat effectiveness. The report's conclusions created a crisis for Chinese leadership. Admitting comprehensive failure would expose years of wasted effort and resources. It would suggest that Chinese manufacturing remained inferior to Western standards, and it would acknowledge that Chinese soldiers had been killed by defective Chinese weapons, a deeply embarrassing admission. The solution was predictable: classification and deflection. The investigation report was classified at the highest levels, with access restricted to a small group of senior officials. The Type 70's failures in Vietnam were attributed to difficult combat conditions and evolving tactical requirements, rather than fundamental design and manufacturing flaws. And the narrative presented to the military and public emphasized successful aspects of the Vietnam campaign while minimizing discussions of weapons failures. Casualties caused by Type 70 failures were recorded as combat casualties without specifying that the weapons involved were Chinese rather than enemy-fired. Families of soldiers killed by exploding launchers were told their relatives died heroically in combat, with no mention that defective equipment was responsible. And soldiers who had witnessed Type 70 failures were informally warned that discussing the problems too openly could constitute revealing military secrets.
The human cost. Wang Disheng, the young private killed by an exploding Type 70, was buried in a military cemetery in Yunnan province. His gravestone identifies him as having died in combat against Vietnam, but provides no details about how he actually died. His family received standard death benefits, but was never told that their son was killed by a defective Chinese weapon rather than enemy fire. Wang's story was repeated at least 30 times during the 1979 conflict. The confirmed number of Chinese soldiers killed or seriously wounded by Type 70 failures. The actual number was probably higher, as some failures likely went unreported or were misattributed to enemy action in the chaos of combat. Each casualty represented not heroic sacrifice, but tragic waste.
young men killed by their own equipment due to manufacturing failures and quality control inadequacies. The psychological impact on survivors was significant. Soldiers who had witnessed Type 70 failures or who had experienced malfunctions themselves developed deep distrust of Chinese-made weapons. This distrust extended beyond the Type 70 to other equipment, creating morale problems and reducing combat effectiveness. Soldiers became reluctant to use new weapons, preferring older, proven designs, even when they were less capable. "I saw 3 Type 70s explode during the war," recalled one veteran years later. "After the second one killed a man in my platoon, I threw mine away and refused to carry another. I'd rather have no anti-tank weapon than carry something that might kill me. And I never fully trusted Chinese equipment after that. Every weapon became suspect. Would it work as designed, or would it malfunction at the worst possible moment?" The engineers and technicians who had worked on the Type 70 faced different consequences. Wu Jianguo, the program's technical director, was removed from his position and demoted. Several quality control supervisors were disciplined for allowing defective weapons into production. But there were no criminal prosecutions or severe punishments. The failures were attributed to systemic problems rather than individual malfeasance, and punishing individuals too harshly might encourage them to reveal details about the program's failures. "We all knew the Type 70 had problems," one engineer admitted decades later, after enough time had passed to speak more freely. "But we were under intense pressure to produce results quickly. Engineers who raised concerns too loudly were sidelined or transferred. Factory managers who rejected too many defective units were criticized for hampering production. The entire system incentivized hiding problems rather than solving them. The result was inevitable. We produced weapons that looked acceptable but were actually dangerous. And soldiers died because we couldn't be honest about our limitations."
The lessons that took decades to learn. The Type 70 disaster was part of a larger pattern of Chinese weapons development failures during the 1970s and 1980s. Time and again, attempts to reverse engineer Western weapons produced inferior results that sometimes proved dangerous to Chinese soldiers. The pattern was consistent: acquisition of Western weapons through various means, overconfident assessment that copying would be straightforward, discovery that Western weapons incorporated manufacturing sophistication that couldn't be easily replicated, pressure to proceed despite problems because failure was politically unacceptable, inadequate testing that didn't reveal flaws that would appear in field use, catastrophic failures during actual combat employment, and classification of failures and deflection of responsibility. This pattern reflected fundamental weaknesses in Chinese military-industrial development during this period. The focus on rapid reverse engineering meant that Chinese engineers never developed deep understanding of the principles underlying weapon designs. Manufacturing quality control was inadequate, with production quotas taking priority over ensuring that products met specifications. And the political environment made honest assessment of capabilities dangerous, creating incentives to hide problems until they became catastrophic. The Type 70 was quietly withdrawn from service in the early 1980s and replaced with indigenously designed weapons that, while less sophisticated than the law, were at least reliable. The remaining launchers were either destroyed or relegated to storage where they could do no further harm, and the program became an unspoken cautionary tale within Chinese defense circles, a reminder of what happens when political pressure overrides engineering judgment and when copying without understanding produces dangerous results. China did eventually develop effective anti-tank weapons, but through a different approach. Rather than trying to copy the law directly, Chinese engineers studied the underlying principles and developed designs suited to Chinese manufacturing capabilities. The PF-89 and later PF-97 launchers, introduced in the 1990s, were effective weapons that reflected accumulated Chinese experience rather than attempts to copy foreign designs. They worked because they were designed from the beginning to be manufacturable with Chinese industrial capabilities rather than attempting to replicate American manufacturing that China couldn't match. We learned, painfully, that you can't copy your way to capability, a Chinese defense official said in an internal review years later. The Type 70 failed because we tried to replicate American manufacturing without understanding the industrial ecosystem that made the law possible. When we finally developed our own designs, optimized for our capabilities, we succeeded. But we wasted years and killed our own soldiers trying to take shortcuts that didn't work.
The forgotten victims. More than 4 decades after the Type 70's catastrophic failures in Vietnam, the weapon remains largely forgotten, even within China. The program's failures were successfully covered up, with few people aware of how many Chinese soldiers were killed or wounded by defective Chinese weapons rather than enemy fire. But those who served in Vietnam and witnessed Type 70 failures remember, carrying memories of comrades killed by exploding launchers and the betrayal they felt when their own equipment proved more dangerous than enemy weapons. Wang Dexiong and the other soldiers killed by Type 70 failures are commemorated as heroes who died fighting Vietnam, with no acknowledgement that they were actually killed by defective Chinese equipment. Their families were never told the truth about how their sons and husbands died, and the engineers who built the flawed weapons carry guilt about their role in deaths that could have been prevented if honest technical assessment had been allowed to override political pressure. The American M72 LAW that inspired the Type 70 continues in service with U.S. and Allied forces today, more than 60 years after its introduction. Continuous improvements in quality manufacturing have kept the basic design relevant and effective. The Chinese Type 70, which was supposed to match the LAW's capabilities, lasted barely 5 years before being withdrawn as too dangerous to use. The contrast illustrates the difference between genuine engineering excellence and attempts to copy without understanding. One produces weapons that endure for generations, the other produces weapons that kill the soldiers carrying them. The Type 70 story deserves to be remembered not just as a failed weapons program, but as a human tragedy resulting from a system that valued political objectives over technical reality, that punished honest assessment of capabilities, and that sacrificed soldiers' lives rather than admit that shortcuts don't work. The young men who died firing defective launchers were victims not of enemy action, but of a military-industrial system that prioritized rapid results over soldier safety, that hid problems rather than solving them, and that measured success by appearance rather than functionality. Their deaths were preventable, their sacrifice was meaningless, and their memory has been buried beneath layers of classification and official dishonesty that served political interests while denying truth to those who deserved to know why their loved ones really died. The Type 70 remains a monument to hubris, incompetence, and the human cost of weapons development that prioritizes political objectives over the lives of soldiers who will depend on those weapons in combat.